Now we're here to talk about the range, the mean deviation, and the standard deviation for a new unit. Now look at it. Range, first of all, is something you're used to. When we talk about range, actually, range is just the difference, that difference between the highest and the lowest. If you have values like, maybe you have values like 3, 4, 17, 22, 3, 5, 0, 9. The range is highest minus lowest. So the highest value actually here is 22, and the lowest value, looking at it, is, I'll make this 10 for example. So the lowest value here will be 3. So if I have this 22 minus 3, that will be 19. Yeah, this is 10. So we have 3, 4, 17, 22, 3, 5, 10, 9. So if you have values like this, the highest of all this value is 22 and the lowest is 3. So remember, the range of any value is the highest value minus the lowest value. So that's what we call the range of a measure for dispersion. But basically now I want to talk about something else. I want to talk about the mean deviation. The mean deviation is something else. Mean deviation is something you are used to partially. Now, check this out. Checking this now. You remember that thing called mean. Mean is EFX over EF, if you remember that. Now, if you look at this statement here, you observe that there is bar X here. And that bar X stands for mean. So anytime you are calculating mean deviation for ungrouped data, mean deviation for group data, whenever you are calculating mean deviation, always remember that the first thing you will calculate is the mean, which is bar X. Even when you come to grouped data, the first thing you will calculate is. So immediately you have the value for this. You already know your frequency. You are good to go. Every other value is settled. Now, we already know the value of range. So we're going to take a very simple question on mean deviation. So let's do that. Now it's easy to talk about this. So find the mean deviation of this. So the mean deviation, these are data that are ungrouped. So the first thing we're going to do is to calculate the mean. And how do you do that? Mean is the value added 2 plus 3 plus 5. So you have values plus minus 1 plus 6 plus minus 3 divided by 1, 2, 3, 4, 5, 6. So that's 6. So the whole total number is 6, which gives you the number, which is still the same thing as for a mean, which is xn is EX over n. That's for mean of ungrouped data. Now from here we can consider the rest, in the sense that since there is no bar value, you can start adding now. So we have 2, 3, 5, that's 10, plus 6, that's 16, minus 1, minus 3. So that becomes 16 minus 1. That's automatically xn is equals to 12 over 6, which is automatically 2. So now we know that the mean is 2. So how do we find that thing called mean deviation? So the mean deviation now is summation of bar x divided by n. It's simple. Don't forget, for that of group data, you see it is summation f. But for on group data, it is n. Now, from here, we take it as values of continuation. Now, values of continuation in the sense that you have something that has to do with ND now becomes the first value we are having is x minus this bar. So that bar shows that there is no negative, there is no positive, everything is positive. Because the reason is because minus p bar is equals to p. Always remember that. Minus p is equals to p. So that is a module last statement. Okay, now from here you have m dot d. For the m dot d, it's easy for me to write something like this. md is, for the first value I will have 2. So that will be 2 minus, what did I get as my x, which is 2, plus the next one is 3. So it is x minus my main, and that x now is 3 minus 2. And the next one will be 5. That will be 5 minus 2. I will have the next one to be, minus 1. That will become minus 1 minus 2. I will have plus 6 minus 2. And the last but not the least, I will have minus 3 minus 2. So they are all bars divided by their number. What's their total number? Their total number is 6. Now, let's take it from here. So 2 minus 2 will be 0, plus 3, that's 1. 5 minus 2, that's 3. Minus 1 minus 2, that's 3. But there is no minus, it's going to be plus 3. So 6 minus 2, that's 4. 4, that's plus 4. And now minus 3 minus 2, which will become plus 5, because it's a bar. Immediately it leaves the bar, it becomes positive. So from there you have 6. Now, 1 plus 3. 1 plus 3 is 4. Then you have plus 3, that will be 7. 7, that's 11, that will be 16. So automatically you are having 16 divided by 6. I believe that should be approximately 2.66. So now you can see how simple it is to calculate mean deviation as far as on-group data are concerned. It is simple, just follow the formula. X minus this bar for the next, for the next, and for the next. But make sure you calculate your mean first. Immediately your mean is calculated, that is the bar X that you have. Immediately you have the mean, you're good to go. So the next thing we're going to discuss is how to calculate this same mean deviation for data that are grouped. Good. Now, taking out our calculations from here, it's easy to say that from the question we're given, it said estimate the mean deviation of these scores. You have 5, 1, 10, 7, 15, 3, 26, 25, 4, and 32. From here, it's easy to say that the first thing you do is to pick up the value of x, and that is the value of the score. You outline them. After outlining, you take the frequency you outline. These two values are already given to you. And the total frequency given is 23 when you add everything together. So from there, let's see something else. You observe that you can multiply the frequencies together. What are you looking at? You are looking at the fact that the first thing is that x is given as summation fx over summation f. If I have to calculate this using this summation, it's easy. How do I do that? Let me see. From here, I can calculate the value of x. If I take the calculation of x from here, what it will give to me is that it shows that I will be having these values times this value, this times this times this times this times this times this, until I finally get the final value of f, which is 17 points. That's 17.39 value. Now, if that's the case, 17.39 as value, which is the value of x bar x. So from your continuation, it's still the same thing. You cannot have yourself having x bar. If you calculate the main of this, which we are already used to calculating main, the main of this is 17.39. So 17.39 is the main. Let's start taking that. So x times f will give me the rule of this. 5 times 1, 5. 10 times 7, 70, 15, just like that. And the whole sum of fx is 400. Now, x minus by x, what you get is, what it means is that x minus the value of 17.39. 17.39 is the value of by x, which is the main of the whole of this distribution. So by the time you subtract them, this is what you get. Now after that, you now get for the value of bar. What is your target actually? Your target is that the main deviation that you're looking for is summation of f x minus by x divided by summation of f. You are looking for this value. That is why you have this. So automatically, after taking them out, bar meaning the same value here is the same thing here, but the difference is that the bar has created that thing that cancels out the minus. So it's still the same thing, but the minus is no longer there. So when you sum them together, it gives you 45. So the whole summation of this thing out here is already 45. So now, after knowing that, the next thing we're going to talk about is knowing to know the summation of f and bar this. So by the time you take it down, you discover that what you see is 12.9 down, and the whole summation of it is 142.61. 142.61. So automatically now, what now gives me my main deviation? Now, EF, what is the summation of all the F? The summation of all the F is 23. So automatically, my main deviation, which I know is the summation of F bar x minus bar divided by EF, will now become, my main deviation becomes, whatever I get here is the summation is 142.61 divided. What is the summation of EF? EF itself as a value, the summation of everything EF is 23. So from there, the value of our MD now becomes 6.2. So that is the value of our main deviation. So this is how you calculate main deviation as far as ungrouped data are concerned. The first thing, you get your value, you outline x, you outline f. Then after outlining them, you start taking out the value with respect to x minus by x. And first of all, you calculate your main, which is which is called by x, EFX over EF. Now that is that. So we'll move to the next stage, which we are used to. It's called the standard deviation. Now, let's talk about standard variation. You cannot talk about the standard variation or deviation without talking about variance. Variance is, as ungrouped data, variance is summation of this divided by the number. And for group data, the same reoccurrence. The only difference is with main deviation is that it has a square of a value. But the truth is that standard deviation itself, standard deviation will give us the square root of variance. Now from there, we're having standard deviation, variance, and then. So let's calculate this question on variance. It said find the variance of 24536. And that variance is the variance for ungrouped data. The data we're looking at are scattered, so they are ungrouped data. Now, basically, if you're having ungrouped data, we'll first of all have to calculate. If you take a look at this, we'll have variance is summation by x minus x bar squared divided by n. But looking at this closely, you'll discover that the first thing we'll calculate is to first of all calculate our arithmetic mean. The mean. For us to calculate the mean, you remember how to calculate the mean. You take the value 2 plus 4 plus 5 plus 3 plus 6 divided by 1, 2, 3, 4, 5. So that will give us 2, 4 is 6, that's 11. 11, that's 14. 14 plus 6, that will be 20 divided by 5. Automatically, that will be 4. Now, the mean is 4. So how do you get the variance now? The variance becomes easy. All you need to do is to reckon with your bar. So variance now becomes summation of this. So the first value is 2. So you have 2 minus 4 all squared plus 4 minus 4 all squared. What again? We have 5 minus 4 all squared. The reason is because it's x minus mean. X minus mean. So this is the first x minus mean. X minus mean. X minus mean. So we still have plus. The next one is 3 minus the mean, which is 4 all squared. And the last one is 6 minus mean squared. All divided by the value n. And that n is 5. So from there we can have something like this. So 2 minus 4 squared. 2 minus 4 squared will give us minus 2. And in representing that, that will become minus 2. That's minus 2 squared. That is 0 squared. We have 1 squared. We have minus 1 squared. And we have 2 squared, all divided by 5. Now if that's the case, we'll continue by saying variance becomes minus 2 squared will be 4. 0 squared will be 0. 1 squared will be 1. Minus 1 squared will be plus 1. And 2 squared will be 4, all divided by 5. Now 4, 1, that's plus 1 plus 4. So 4 plus 0 plus 1, that's 5, 6. 6 plus 4, that will be 10 divided by 5. So therefore the variance is equals to 2.0. So that's the variance. So now you observe that calculating variance as far as ungrouped data is concerned is very simple. The first thing you do, you just get your mean. After getting your mean, you substitute into your formula. How is that? The first thing you get your mean. Well, we got our mean, we got mean to be 4. Then we discover that it is x, the value, minus our mean, all squared. So the value minus our mean, summation of it, summation, sigma, summation, summation. That's what it means. So from there, you just take the first value. 2 minus that, that's 2 squared, minus 2 squared. Take the next squared, take the next, divided by 5. Then you have the same thing divided by 5. Then you take your computation down, 410. So that makes our variance to be equals to 0. So it makes it easy. So now you can now ask yourself, from here now, it's simple. If somebody now asks you to calculate the standard deviation of this, standard deviation of this is the square root of the variance. So square root of this variance is 2. So square root of this will be 1.414. So something of that nature. So from here you have standard deviation. So let's consider variance now in group data and also consider standard deviation in that part. So from there, we'll move on to the next stage. Now we have standard deviation, but now we are talking about question that has to do with grouped data. That is, data that are not scattered. Now, take a look at this question. It says estimate the variance and standard deviation of the frequency table. Now, the weight is given, which is the value of x. They are given in pairs. Now, you have number of students. The number of students is the frequency. You have 6 students, 2 students, 3 students, just 1 student. Now, I'll take the first value. You remember that whenever you're doing your calculation, you have to find the value of the mean first. And that is EFX over EF. And what is my EFX? My EFX over EF. Now, if you look at that carefully, you'll discover that the frequency and the total of the frequency, if I calculate my EFX, that will be, I'll have values like this is 6, and I have values like adding all these values in different pairs. So you have 6, 2, 3, 1. So this fx, which is summation of fx. Now this is f, and that's summation of f. So by the time you take that together, you'll be able to get your value of mean deviation. So that gives us a value that is very direct. So from there, you can take it out and say, okay, my value is 139 divided by 12. So that will be 11.58 approximately. So from there, you have that. So if you start subtracting your values, this minus that, you have 11. So for x value taken out, you get something of this nature. 58. You have 0.17, this value for a squared, and this. And now, after having that as your direct values, after having this as your direct, after your subtraction, you also have values like f negation this, negation that, negation this, and that gives you a total of 322.89 as standard value. Now, it's easy from here for you to calculate your variance. And your variance, you should remember, is EF. You have x minus by x all squared divided by EF. And your standard deviation is the square root of the variance. So it's easy. So basically, raw out your values, get a standard clue, and raw out your calculations in terms of knowing the value of x, fx, x minus by x minus by x squared, then frequency multiply by whatever is here, and it gives you a total of this. So, ladies and gentlemen, we'll round up this unit with standard deviation. Thank you. I'm your math instructor. We'll meet in other classes.